Identify the major product of the reaction, and the reaction is given by two molecules of HBr is added over the cyclohexadiene system having two groups, and one of the double bond system methyl group is present, on the other double bond system nitro group is present. Here this is acting as source of electrons, hence it is electron rich. On the electron rich, electron deficient like H plus initiates the reaction, hence this reaction is electrophilic, and moreover here addition is taking place, hence the nature of reaction is electrophilic addition reaction. Nature of reaction is electrophilic addition reaction. Whereas here the electrophile that initiates the reaction is H plus. H plus is having vacant orbital, followed by the corresponding nucleophile that completes the reaction is Br minus. Both are getting generated from the HBr. And moreover, there are two double bonds. At one of the double bond, methyl group is present. At the other double bond, nitro group is present. If we focus our attention towards the nature of the groups present on the double bond part of the cyclohexene system, this particular methyl group is offering, that is sigma electron density is transferred towards the cyclohexene system. That is, regarding the methyl, if I talk about its nature is plus IE nature, and also it is acting as plus hyperconjugative group. Whereas this plus hyperconjugative nature dominates the plus IE nature. Due to this nature, electron density on this double bond will be higher. And if I go for nitro group structure is present in such a way that sigma bond is connected to N, double bond O followed by O. Oxygen is relatively more electronegative compared to the nitrogen. Hence what happens is this pi bond electron density is in favor of the oxygen. So nitrogen becomes electron deficient, hence it will becomes minus mesomeric effect group, and at the same time it is also acting as minus inductive effect group. Due to these two natures, this group is acting as deactivating group. This group is acting as deactivating group, whereas this particular methyl is acting as activating group. As being methyl is activating group, at the methyl substituted double bond, electron density is higher compared to the nitro substituted double bond. So therefore, at this double bond portion, in the beginning, electrophile want to initiate the reaction and it completes. Then the second molecule of HBr takes a chance to be attacked over the double bond connected with the nitro group. If we write the stepwise process in a sequence manner, that is mechanism, including the intermediate and the process involved in the transformation of addition of HBr over the two double bonds present on the cyclohexene connected with methyl and the nitro groups is given by. So let us go for the mechanism. Here H plus will initiate the reaction because H plus is electron deficient. This pi bond species is acting as electron rich. And here it is secondary carbon, whereas this carbon will become tertiary carbon. If tertiary carbocation is generated, it becomes more stable in nature. So therefore attack takes place in such a way that this nitro group remains intact, whereas here the H plus will initiation takes place, and here it is generated as corresponding cation. It is getting stabilized because it is connected with the methyl, and it is having alpha hydrogens here too. Here already 1 plus 1 2 are there, so it is tertiary carbocation. It becomes stable. On that, this Br minus as nucleophilically on the sp2 carbon makes an attack. So therefore this results into the formation of, this is methyl followed by this is bromine, and here the remaining system remains as what? Intact. On this, the second molecule of H plus initiates the reaction. There are two chances. This is secondary and this is also secondary. But here if it is present, this group is minus Me in nature. So therefore cation becomes less stable. Due to that particular reason, here what happens is our H plus makes an attack at the nitro place and generates at the alternative position this cation, and this cation is getting for the next part attacked by the Br minus. As a result, the product of the reaction appears to be, here methyl is connected with bromine, whereas nitro position is connected with hydrogen and its adjacent position is getting connected by the Br minus. Like this product formation takes place. So therefore the product of the reaction is associated with addition of H plus, generation of relatively stablest carbocation, that is secondary versus tertiary, that is tertiary carbocation, followed by Br minus attacks over the possible stablest carbocation at the place of carbon where methyl group is making contact. Then after second atom of H plus, second H plus ion makes the initiates the reaction and it will generate relatively stablest cation. That is the cation where H plus is connected to NO2 and adjacent position cation is getting generated. On that Br minus makes an attack, thus it results into the formation of bromine substitution at the place of methyl connected to the ring, bromine substitution at the adjacent to the nitro group in the cyclohexane system.